Howdy! Welcome back to Science with Mr. Ike. Today we're going to look at the layers of our wonderful planet Earth. So scientists have divided the Earth, or the inside of the Earth, into four very distinct layers. The crust, the mantle, the outer core, and the inner core. And here it says approximately how thick these layers are. Let's take a closer look. Let's look at the crust. The crust is only between 5 and 40 kilometers deep. So if you were standing on top of the ground, say right here at school, and you were to look down, the crust would be somewhere between 5 and 40 kilometers below you. That's anywhere about the distance from the center of Wayland to the distance from here to Boston. It's not very deep and doesn't take up much of the Earth. The crust is the Earth's solid and rocky outer layer, and it includes both the land surface that we were standing on, and it also includes the ocean floor. So here are our oceans. So if you go down underneath to the bottom of the ocean's floor is part of the crust. The crust is thinner under the ocean, and it's thickest under the mountains. Our mountains are actually considered part of the Earth's crust, so it would make sense that it's a whole lot thicker. Hills, high areas, they're all part of the surface of the Earth and part of the Earth's crust. The oceanic crust is mostly made up of a particular kind of dense rock with a very fine texture, and it's very, very dark. It's called basalt. The continental crust, which is what we're actually on, what our Curtis School is built on, what your house is built on, where we live in Sudbury, that crust is mainly made up of less dense, larger rock called granite. And I'm sure you've all seen examples of granite. It tends to be the gray stone that we find right around here. In fact, maybe you can think of what the granite state is in New England. It's the nickname for a particular state. Let's take a look at the mantle. Underneath the crust is the mantle. Now that is the orange area here, and it's almost 3,000 kilometers deep. So below the crust for 2,900 kilometers is the mantle. There are some really neat characteristics of the mantle. Let's look at them. First, the mantle is hot but solid rock, and it lies between our crust and the core. The deeper you go into the mantle, say from the crust down towards the end of the mantle, towards the core, the more pressure and temperature increases. Think of yourselves diving into a pool. Have you ever gone down to the bottom of the pool to pick something up, or maybe in the ocean? What happens to your ears? That's actually pressure. And that pressure gets far more intense the more you travel down into the Earth. You may be surprised that no one has ever gone to the mantle. In fact, no one has been able to dig deep enough to get to the mantle. No drilling tool has ever gone as far into the Earth as to get to the mantle. The crust and the upper mantle form a rigid layer called the lithosphere, and that would be the very top part. So again, the mantle is divided here into different parts. Below that, the lithosphere is the lithosphere is actually about 100 kilometers thick. So again, we're not going too far into the Earth, and it floats on the rest of the mantle, which is called the asthenosphere. Try saying it, asthenosphere. I didn't hear it. What? That's right, asthenosphere. The asthenosphere is the lower and softer layer of the mantle. So we have the crust and we have the mantle. Now let's look at the core. Here's the outer core. It gets really hot down here. The outer core is a layer of molten material that surrounds the inner core. It is so hot and under so much pressure that the material there is always molten or melted. Even though there is immense pressure, the outer core acts like a thick liquid. So believe it or not, this is still a moving material. It doesn't move anywhere near as quickly as what we're used to here. In fact, think about the slime experiment that we had recently, and remember how slowly the slime changed state? Well, the material inside the core probably moves hundreds if not thousands of times more slowly, but it is moving. The outer and the inner core are both made up of the same two elements. They're metals, iron and nickel. But the outer core is ready for this approximately 2,200 degrees centigrade. Can anybody figure out what that would be in Fahrenheit? The inner core, ready for this? The inner core is a dense ball of solid metal. So it's made out of iron and nickel, but it is still completely solid, and that has to do a lot with the pressure and the temperature. The inner core temperature is approximately 5,000 degrees centigrade. And the outer and inner core are approximately 1/3 of the Earth's mass, meaning most of the material in the Earth, 1/3 of it is actually in the outer and inner core. But only 15% of its volume, and it takes up only 15% of the space of the planet. So 1/3 of the heaviness, or the mass, the material really, heaviness being determined by gravity, but 1/3 of the material that is in the entire planet is right here in the outer and the inner core. But it doesn't take up a lot of space, and that's what's called volume. So here's another way to look at it. Here's the crust-to-core cross-section. We have the oceanic crust, and we have the continental crust. Remember, the oceanic crust is actually thinner than the continental crust. It doesn't look that way here. Below the crust is the mantle, and in the mantle we have the lithosphere, which is actually part of the crust, as well as the mantle, which is in two parts, the asthenosphere, which is floating on the rest of the mantle. Then we have the outer core, which is made of iron and nickel, and it is molten, and the inner core, which is made out of iron and nickel also. It is much hotter, and it is solid. And scientists believe that it's solid because there's so much pressure on it that the atoms can't even move. It's much hotter, which would lead you to believe that this metal should be liquid, but it can't move anywhere, so it's kept in a solid state. One of the questions I have is, how do scientists know all this? We'll have to discover more when we talk again.